Yeah, good morning, everyone. I want to begin by thanking the organizers, not only for organizing this fantastic event here this morning, but also for accepting our contribution to the discussions here. It's a real pleasure to be here this morning. So my name is Christoph Deuster, and I'm currently working for the Joint Research Center in ISPRA of the European Commission. And what I want to do in the next 10 minutes or so is to attempt to give you an overview about the research activities of the JRC in the area of climate change, disaster displacement, and mobility, ongoing and most recent work in this area. That being said, at the JRC there's a big team of people working in this area, many parts of the presentation is going to be on their work, so big credits goes to them. I'm highly indebted to these colleagues. All right, something that is probably well known and a view that is probably shared among many of the experts audience here. What I want to begin by this observation. We have seen that policies, and with it to some degree research questions, have been evolving from ad hoc initiatives and definitions of migration and climate change as threat multipliers to somewhat more integrated, holistic policies on climate change, adaptation and migration. So there was a move sort of from this question of how many will migrate due to climate change, so this typical story of the millions of climate migrants, to the question of how many will actually be exposed and vulnerable to the adverse consequences of climate change, so also those people trapped in extreme situations. Based on these observations, colleagues started to work in the so-called CLICIM project, the climate change-induced migration project, on the objective to provide evidence on the nexus between climate change and population dynamics with a specific focus on Africa. The idea was to focus on the role of climatic factors in affecting population exposure and vulnerability, and also link that somewhat to human mobility, migration, all at a very high spatial resolution. And this is something I want to stress here. This is what we believe is key for this type of analysis, to have a very detailed granularity spatial focus, which will hopefully become clear in a couple of slides. Okay, parts of the CLICIM project was to provide estimates of the exposed and vulnerable populations to climate change, and for that I have to refer, to give you some idea what this is about, to the SSP RCP scenario framework. I've seen that in many presentations here already, so I don't think I need to explain that in detail. What was done for this project was to focus on specific RCPs, which somehow capture the effects of emission, and compare estimates or projections for population across the different set of SSPs. So this project focused actually on the sort of two extremes of RCP 6 as the more negative extreme, and RCP 2.6 across the different SSPs. So in a nutshell, the approach was actually to geographically overlay projections of demographic and socioeconomic indicators based on the SSP scenarios on projections of changes in agricultural productivity based on the RCP scenarios. So productivity changes across a set of different crops. So in terms of scope of the study, the idea was actually to look at projections for the year 2070 for the African context, so for Africa, at a very high spatial resolution grid, so 0.5 times 0.5 degrees, which, as you might know, refers roughly to 55 kilometers at the equator. And I plotted here on the right-hand side a graph just to give you sort of an idea of the detailed level of granularity, which depicts the difference for each of these cells between the projected populations between the SSP1 and SSP3 scenario. Takeaway message from that graph is not only that it's a very detailed sort of granularity approach, but also that there are important differences in terms of distributions when it comes to projecting these populations according to the different SSP scenarios. So for the study here, exposed populations were defined at the number of peoples that were living in territories where agricultural productivity falls by more than 20% in 4 different types of crops: maize, wheat, soybeans, and rice. And when it comes to vulnerability, the definition was according to sort of 3 dimensions. First, those populations that live in rural areas. Second, those with extreme low levels of education, meaning a level of primary education or less. And the extremely poor as a 3rd dimension, meaning those living from less than $1.9, according to a very standard definition. Okay, let me jump to the findings. So in terms of main findings, on the left-hand side here, you see actually the results for the share of exposed populations. When looking at these projections, so what you see on the x-axis are actually the different SSP scenarios for these 5 different macro regions in Africa, according to the UN. And on the y-axis, what is measured here is the share of exposed populations. Key takeaway message from this first finding graph here depicted is actually that there's not only some level of heterogeneity when it comes to the effect of exposed population projections in the African context. You see that Western Africa and Northern Africa tended to be the regions most affected in terms of exposure, but also that the RCPs tend to play a bigger role compared to the differences between the SSPs when it comes to determining exposed populations. Jumping to vulnerability, the first indicator of vulnerability, those living in rural populations, we still see this level of heterogeneity, but what comes out here from this graph is maybe the conclusion that the SSPs tend to play a bigger role. So the way to read this graph here, for example, is that when you look at the combination of the SSP3 scenario and the more negative RCP 6.0, you see in Western Africa that the share of roughly 9% of the population was exposed rural populations for this region. Jumping on to other sort of dimensions of vulnerability, we get sort of a similar picture for low levels of education or extreme poverty. Again, some heterogeneous picture when it comes to exposure. So coming to the key takeaway messages, what this project found was actually that there were high levels of exposure in certain African regions, and it sort of identified also with this high level of granularity several hotspots of exposure and vulnerability across the African continent. Interestingly, when it comes to most affected regions, one region that could be sort of identified as most affected was Western Africa. And based on this observation of combining the SSP and the RCP scenarios, it highlighted in a way that there's not only the need to address the adverse consequences of climate change to climate policies, but also based on this comparison of SSP scenarios, the project emphasized also the need of development policies for addressing the adverse consequences of climate change. However, it also displayed somehow how difficult it is to quantify the number of migrants within exposed and vulnerable populations, which brings me sort of to the last 2 slides in terms of next steps. The idea is actually to quantify the number of migrants within exposed and vulnerable populations, which is of course sort of the elephant in the room, the extremely difficult task. This is a bit more related to the ongoing activities which we try to do right now. So we began by doing that by focusing on forced displacement specifically, and we extracted the spatial dimension of global data on forced displacement from a database probably well known from IDMC. So again, the idea is here to have this spatial detailed focus. And in the first step, we began to assess the geographical interaction with data on disaster from famous MDAT. So this database from Belgium. And the idea in future will be to explore somewhat the correlation and disentangle the complex factors that play a role here when it comes to this sort of disaster displacement. But I have to say here, this is very preliminary work, still in progress, which brings me to the absolute last slide and probably the worst slide of the presentation as well, because again, this is based on ongoing work. So I began just to investigate here the correlation between disasters as I find from the MDAT database and displaced populations for the year 2021. I isolate that effect for floods, so this is just a display for floods here. And actually, it's what you see here on the graph is the match for specific cell and month observations for the year 2021. On the x-axis, the number of affected populations based on MDAT. On the y-axis, those that are displaced according to IDMC. So there's some picture of correlation between the two, even though it's not quite perfect yet. But this idea of actually measuring vulnerability, linking to affected people here, having some impact on forced displacement based on information from the IDMC was actually motivating sort of this type of analysis, but still ongoing. We plan to do that for different type of disasters and also look on other forms of mobility patterns. With that, I want to thank you. I want to, as a last word, just give you a heads up that we are working currently on a policy report, Science for Policy report, that will probably be published hopefully in the first half of the coming year on these topics, which I of course invite you when it's available. It's along these lines, and hopefully we'll have some more of the research results in there. Okay, thank you very much.